Hey, let's have some fun by graphing a sort of a fun exotic function. G of x equals negative 2 times cosine 3x. How do we go about that? Well, first, let's just start off by remembering, thinking about, or seeing for the first time, what cosine of x looks like as a function. Well, cosine of x has a very pretty picture, pretty graph, and I want to sort of show it to you. Here's my artist's rendition of it. And you can see that this function is periodic with a period of 2 pi. If you notice right here, if we take this little piece right here and just slide it over, it begins to repeat again and again and again. So now, this 3 will change the period, and the negative 2 in front, which we've already seen in many examples, will change in some sense what we call the amplitude, how high and low the function is going to go. It's a vertical stretch, basically. And the 3 multiple in front is going to either compress, and so we have lots of wiggles, or stretch out, so we have to wait a long time for those wiggles. It just depends. So let me actually show you how to transform these functions. So in either case, if we have y equals a sine bx or y equals a cosine bx, it turns out that the amplitude, which is the height of the highest points here, will be the absolute value of a, which in this case will be the absolute value of 2, the absolute value of negative 2, which equals 2. So that means that we're going to have a stretched thing here, and these will stretch down. And the period will always be 2 pi divided by the absolute value of b, where b is the coefficient in front of the x. So what do we have in this particular situation? Well, in this particular situation, what we have here is, first of all, we're going to pull this up so that we have 2 cosine of x. This graph, by the way, let me just label this so we know where we are, is y equals cosine x. Now, y equals 2 cosine x is going to look like this. Every point is going to be stretched 2 units up. So this point is going to come up here. This point is now going to be stretched 2 units down. Everything gets just multiplied by 2. Where I'm 0, though, I remain 0. And so now I see this. It's much more exaggerated. It's an exaggerated cosine function. I'm making it deliberately a little bit wavy so you can sort of see it. That is y equals 2 cosine x. Now, what's y equals negative 2 cosine x? Well, we know how to do that. We just take this picture and literally flip it over the x-axis. So this 2 becomes a negative 2. All points become the opposite. So what we see now is this. And so this purple is getting really close. This is y equals negative 2 cosine x. Okay. Now we've got to deal with the period. So how are we going to deal with the period? First of all, let me just show you sort of a really nice sort of artist rendition of what we got going on so far. So here we started off, just to summarize, with just the cosine function. And where we are now is we first put the cosine, 2 cosine, which just sort of stretched everything by 2. And to get the negative, we just take this picture and flip it. Whoop. And now that's where we are right now. Now what we want to do is we either want to compress or expand by changing the period. And how much are we going to change the period by? Well, the period is going to be 2 pi divided by b, in absolute value of b. In this case, b is 3. So we have 2 pi divided by 3, which is 120 degrees, which means that instead of waiting for 2 pi to make a complete cycle, we're going to actually scrunch that in, and we're going to make a complete cycle in actually 2 pi over 3 radians, or 120 degrees. We're going to make a complete cycle. So we're going to see our shrinkage in like that, and when we do that, here's what we see. Do you see how tight it is, how many more we get in? Because we shrunk it in. Here was the original one, and now we shrunk it into there, and that actually produces the graph of this particular function.